A question that gives you a lot of visual data. And how do we sort through that visual data? So I'm actually going to give you a minute to try this one on your own. Look really carefully. And again, try not to memorize anything. Just see what do the different visuals represent, and then see which choice is a conclusion that can be reached from the information on the map. I'll give you 1 minute for this one. And when you have an answer, put your answer in the poll that's going to pop up on your screen right about now. Good luck. All right, let's take a look at this one together, folks. The map shows Earth's continents, the outlines of the plates that make up Earth's outer shell, and the location of volcanoes. Which conclusion can be reached? So again, please don't look at the answer choices and play the answer choice game. Instead, let's just figure out in general what that visual data is saying. So you notice I popped that out a little bit. So if you notice here, first in the bottom right corner, and this is something you always want to look for when you have like a map or something where they give you this indicator. Sometimes it's called a key, sometimes it's called a legend, but basically the idea is to kind of sort out what the different colors represent or the different lines represent. So if you notice, the yellow represents the active volcano. So all those little yellow dots, right? All those yellow dots are volcanoes. The black lines are the plate boundary lines. If you notice, oh, we have those lines, kind of like squiggly lines all over. And the red line is simply the equator. And the equator, basically, again, that red, well, I shouldn't make it purple, but that red line that kind of cuts through the middle there. Do you notice anything about the yellow and the black, or the yellow and the red, or the red and the black, just from your first look at this map? What do you notice here regarding the map here? Yeah, that the yellow kind of surrounds the black, like, well, not right. So it's not saying that the yellow is everywhere the black is, but the yellow tends to be where the black is, right? That's the pattern, right? So the yellow being the active volcanoes is almost all the yellow dots are right on the black. So the active volcanoes are on the plate boundary lines. So, okay, that's the pattern. Like, Lily, I like to use that word. That's the pattern that you see here in this map. And hopefully that made the question a little bit easier. So notice, notice if you look at those choices, answer choice A, volcanoes are all over the earth. Not really, right? Are the volcanoes scattered randomly across the earth? Like you said, right? Like a lot of you said, the yellow or the volcanoes, they don't seem random. There's definitely a pattern here, right? Take a look at answer choice B. Volcanoes are only located along edges of continents. So just to be clear, what are the continents in this map? What are the continents? Or what indicates the continents? The green indicates the continents. Are the volcanoes only on the edges of the continents? Are they only on the edges of the green? No, they are not. So let's get rid of answer choice B. Answer choice C. Volcanoes are mostly located along boundaries between plates. Well, the volcanoes are the yellow dots, and they're on the black, which is the plate boundary lines. Oh, D, that's a check mark. Got it. Answer choice D is true. Do we have an answer? Well, a strong majority of you, almost 2/3 of you, put down answer choice C, which is indeed your correct answer for this one. Nice work here. Okay. Great work here. All right. Another type of question that you'll see on the GED Science test, right? Asking about experimental design. So not so much like figuring out the experiment, but figuring out what the setup is. Abby, does it make sense now why answer choice C is the correct answer? That's the most important thing, right? Honestly, that's like, if you get a question wrong here, big deal, right? The most important thing is that now you know the process. Now you know what to look for those types of questions, okay? So experimental design questions focus on the scientific method setup of an experiment, right? So there are a couple different sessions you want to check out, scientific experiments on the science section, and even the session about reading strategically as part of the RLA lessons can also help you with scientific design. So going back to that passage about the little fishies, right? The fishies in the water and the CO2, let's take a look at this example. This is an example of experimental design. So take a look at question number 7. A rough hypothesis for this investigation is ocean acidity affects fish hearing. Which statement represents the most appropriate revision for this hypothesis? So notice they're not saying that the hypothesis, the first hypothesis is wrong. They're just saying it's a rough hypothesis. Ocean acidity affects fish hearing. You want the statement that represents the most appropriate revision. So, in your own words, and again, you don't have to reread the passage. If you kept notes while we went through that passage, you might have noticed the theme here, right? Or you might have noticed here, we have the notes. What are some of the ways we can strengthen that hypothesis, make it more direct, make it less rough, make it more specific? How would we revise this hypothesis? Ocean acidity affects fish hearing. Look at what we said here. So stuff that I mentioned here, paragraph 3, paragraph 4, high, do you use the word high? So high ocean acidity, perhaps, is what you're referring to? And what does that do to the fish hearing? Right? So is it enough to just say, yeah, ocean acidity affects fish hearing? Again, it's not wrong, but higher ocean acidity can cause hearing loss, right? It's not just affecting the hearing, it's like making it harm, making it go away, maybe making these fish deaf, right? So again, as a lot of you mentioned, paragraph 4 is where we got a lot of that. All of you mentioned that, right? Paragraph 3 and 4, right? About the results. Higher CO2, the fish did not avoid the predator sounds. Normal CO2, the fish avoided the predator sounds. Take a look at the answer choices. I'll give you, let's put 30 seconds for this one. Since we did a lot of the work already, I'll give you 30 seconds to try this one on your own. When you have an answer, put your answer in the poll. Okay, a few more seconds. All right, let's take a look at this one. So again, the most appropriate, right? The very general hypothesis was ocean acidity affects fish hearing. But more specifically, what did the results say? The results said higher CO2 levels affect the fish hearing. And how do we know that? Because they didn't avoid the predators at the higher CO2 levels. At the normal CO2 levels, the fish avoided the predators. Which of those choices basically says that? The correct answer, as again, a majority of you did put down, is indeed answer choice D. Increasing ocean acidity decreases predator avoidance behavior in fish. Nice job here with this one. Okay. All right, real quick. Again, it's good to know that you got the correct answer. It's even better to know why the wrong answers are wrong. Take a look at answer choice A and tell me what's the problem with answer choice A. Fish hearing improves as a result of elevated dissolved carbonic acid. What's the problem with answer choice A? It's the complete reverse, right? It's the complete opposite, right? It's the complete opposite here. Fish sharing does not improve. It actually gets worse. So we can get rid of answer choice A. What's the problem with answer choice B? Increasing ocean acidity impedes the transfer of sound through water. What's the problem with that? Yeah, if you see what Ruedo mentioned, it's a little too far, right? Because like answer choice B is emphasizing the transfer of sound. Is that what this passage was about? Is that the hypothesis? The hypothesis was about fish and how they move and how they don't hear stuff if there's more CO2. So that's why we can get rid of answer choice B as well. And then lastly, answer choice C. Oh, what's the problem with answer choice C? Because it does sound good at first, right? But what's the problem with answer choice C? I'm sorry, I didn't show you results here, but some of you did fall for answer choice C. But there is a reason why answer choice C is wrong. Tell me what's the problem with answer choice C? And that's okay, Candida. It's okay. But let's figure out why that's wrong. Remember, we want to fix the hypothesis. We want to revise the hypothesis. The hypothesis was acidity affects fish hearing. And if you see what Kaya is that, I hope I pronounced your name right. Answer choice C is wrong because it's too broad, right? Greenhouse gases are dissolved in the ocean. Did the passage talk about greenhouse gases? No, they talked about one type of gas, CO2, but they didn't talk about greenhouse gases in general. Oh no, any greenhouse gas is going to destroy the fish. That's not the hypothesis here, right? The hypothesis was about CO2. Answer choice D is your correct answer for this one. Okay. All right, nice work with this one. Okay, so so that one last type, and oh boy, I don't want to scare you. I hate ending this lesson with this, but there is one type of question in science that you should also be aware of, and that is when, unfortunately, dun dun dun, you may see some mathematical reasoning skills being tested uh, on a GED science question. So again, if you've been studying for the math exams, the math that you'll see on the GED science test is just in line with that. Even if you're not studying for the mathematical reasoning test, it is still doable as long as you know what to look for in a mathematical reasoning test. So here's an example of a question you'd see on the GED science test, but does require a little bit of math. Let's do this one together to finish this one off, okay? A temperature change occurs when ammonium chloride is dissolved in a water solution. The table shows the temperature change over a period of 120 seconds. What is the approximate temperature of the solution in degrees Fahrenheit at 60 seconds? You may use the calculator. And by the way, when it says you may use the calculator, you should use the calculator. All right, so what's the question asking for here? The temperature of the solution at 60 seconds in degrees Fahrenheit, 60 seconds. So here's the thing that you want to be careful of, right? Here's the thing you want to be careful of. You have this table. Do you need all the information in this table? The question's asking for you want the temperature of the solution at 60 seconds. I know it looks so fun, Kai, right? What's the only thing you actually need in this table then? What's the only row? Yeah, exactly. We don't care about 0 seconds. We don't care about 30 seconds. We don't care about 90 seconds. We don't care about 120 seconds. All we care about is 60 seconds. And let's be honest, if the table just had that one row, wouldn't this question just have looked a lot easier? Right? When you have like, you wouldn't have braced yourself, right? But really, this is the only thing we care about. So at 60 seconds, the temperature is 18.8 in Celsius. The question's asking, though, for Fahrenheit. Oh no, how am I supposed to figure that out? What other information did they give you to help you answer this question? The formula, right? To find Fahrenheit, you take the Celsius times 9 over 5 plus 32. So just to be clear, 60 seconds, it says 18.8. Where are we plugging the 18.8 into that formula? Into the F or to the C? We're plugging it into D's. You put it in there in the C. Good. And from here, again, use that calculator. 18.8 times 9 over 5 or Safin. Oh, Safin, you're good with your improper fractions and your decimals. 9 over 5 is the same as 1.8, or if you just did 18.8 times 9 divided by 5. So what does that part give you? And again, if you have a calculator, punch it in your calculator quick. 18.8 times 1.8 or 18.8 times 9 divided by 5. I believe that got you 169.2 divided by 5, which is the same as 33.84. And then lastly, please, someone punch this in your calculator. Don't do the math in your head or don't write it out. What is 33.84 plus 32? It is 65.84, or basically 66 degrees. Answer choice D. Okay. You will see this a lot, and if you attend any of the GD math sessions, you'll see this a lot. When you have tables or charts or graphs, they look intimidating because they give you way more information than you actually need, right? And yes, Adam, there's an on-screen calculator you can use. Um, On-screen calculator you can use as well. But the main point is this: don't get overwhelmed by all that information in the table. The only thing you really cared about was that thing. Okay? All right. Great work here tonight, folks. Again, if you have not done so, last call to download the PDF. There's a lot of extra mixed practice to check out to help you reinforce your skills. But as we wrap up for tonight, again, we've accomplished a lot. Does this mean you're a master at everything we looked at tonight? Unfortunately, maybe not, right? But this is where that extra practice is going to come in, okay? Come into play. But you've done a great, real quick before you all go, just our upcoming sessions. Next Tuesday at 8 p.m. Eastern, by the way, these are all Eastern time, I will actually be teaching the Algebra Part 1 lesson. So if you didn't like the sound of my voice, you can avoid Tuesday. But in all seriousness, if you do want some algebra help, I'll be teaching the lesson on Tuesday, and those are the other sessions we have over the next 10 days or so, okay? Thank you all very much. Have a wonderful rest of your night. Enjoy the rest of your Thursday. Enjoy your weekend, and keep up that good studying to succeed on the GED Scientific Reasoning Test. Have a great night, everyone. Take care. Bye.